So again, hello everyone. I'm also called Nicola, and I work on renewables and wastes annual statistics. So I'm going to walk you through the first of our presentation dedicated to the fuels we collect annual statistics about. For questions, we will have some time at the end of the presentation, so you can always write them in the chat. Some colleagues will reply, and I will go over them again as you saw in the previous session at the end. So let's start from the overview of this presentation. The presentation is divided into 3 different parts. We will start with the key trends for renewables worldwide. Then I will show you the concepts, classification, definition of renewables in energy statistics. And lastly, I'll go over the structure of the renewables and wastes questionnaire. But first, to break the ice, let's start with a question on Menti. So again, you know that you have to go to www.menti.com, and I will give you in a moment the code. Here you go. I hope you can see in the screen. So the code is 77878949. And the question is, which renewable energy do you think takes the largest portion in total energy supply in the world? So I see that the code was written in the chat. Thank you very much. And of course, we're going to share the presentation later on after the training. Here, I want to highlight the fact that we are speaking about the total energy supply. So it's important to reflect on what that implies. I'll give you some time. I see that you're replying, many are replying, so that's a good sign that the system works well. And clearly, hydro seems to be the winner here. So I think we're a lot of participants, not the majority has replied, but the majority of the respondents seems to be leaning on hydro. So we can move on, and I will show you that actually, let's see, solid biofuels was the correct answer. And coming back to the presentation, we will show in numbers why that wasn't the case. So why it's solid biofuels. So here you see 2 pie charts. On the left, you have the world total energy supplied by fuel in 2022, and you see that renewable occupy the 3rd place after fossil fuel with a share of 14%. And you can see that the main component of renewables over here, it's actually biofuel and waste with about 8.4% of the overall total energy supply. Equivalent, if we go back to the right side where there is only the renewables by the different type of fuels, on the right side, you see that biofuel and waste, it's about 60% of total renewables. And actually the vast majority of these biofuels and waste is solid biofuels and charcoal. And instead, hydro, in terms of total energy supply, it's only at the 18%. So it's the 2nd type of renewable, but much after biofuel and waste. So indeed, when we talk about renewables, the first things that might come to mind are the ones that produce electricity. There is not only hydro, but there was also solar PV, and some of you chose that on Menti. But actually, in the world, the most used product is again biomass, which is mainly converted to heat, and it's very largely consumed in the global south and in developing countries for heating and cooking purposes. And here instead, from a growth rate perspective, you see the fuels that have increased the most in the last 3 decades. And instead, you see solar PV and wind, which increase very much. Whereas for hydro and solid biofuels, the increase was much more modest. And this is mostly due to the fact that the technology, the modern one, solar PV and wind, had a very, very small energy supply in 1990, contrary to hydro and solid biofuels that were already extensively used. I want you to focus only here on the left side on the total energy supply in gray and the one for renewables in green. So we see that the renewable pace is slightly higher than the average because of favorable policies for renewables, again, especially for solar PV and wind in the recent years. However, we saw before that the share of renewable over the total is still relatively low. So renewable need to outpace the rest of the fuels growth rate much faster if we want to see a future where they are the main source of energy and many sectors, as industry, buildings, and transport, are decarbonized too. Now, in the chart on the left, over here, you see the geographical relevance of renewable over total energy supply. And we immediately notice that in Africa, renewables have the largest share, about 42%. So we go back to what we said before about the traditional use of solid biofuels in the global south, and that is the case not only of Africa, but also of other regions. We have mostly here Latin America, and in general, all the regions except OECD. And this traditional use generally means burning the fuel, solid biofuels, inefficiently and also with effects on the health of people. And if we go instead to OECD countries, we look at them, we see that biomass is less used and generally in a more modern way, so for producing electricity or heat in dedicated plants. So despite this and despite the fact that renewables deployments were important in OECD countries in the last years, the share is still very low because in these countries there are other energy intensive final consumption sectors as transport that rely heavily on fossil fuels. Going to the right, to the pie chart that shows the sectoral consumption of renewables, the green slice is again the one that show mainly the traditional use of biomass in housings. And then we have instead that the biggest part, luckily, is the one of electricity plants. And it's the one that we should pursue to expand, because on one side, we want to electrify final consumption in general, but also we want to consume as much electricity as possible for renewables, especially if it comes from modern renewables where there is no combustion. And this leads me to the final slide of this first section, where you can see the world electricity production a bit above 29,000 terawatt hours, and in which renewables occupy a better place compared to the total energy supply. They are second after coal with about 29, almost 30%. And also they saw a very large increase, both in relative and absolute terms compared to 2021. In absolute terms, it was about 650 terawatt hour according to the statistics that we collected. And within renewables, instead, for what concerns electricity production, hydro is the most widespread technology. However, solar PV and wind over here, aggregated with some others, but that's mostly solar PV and wind, are just behind hydro, and they're growing much faster. And this is a good thing, but also poses some new challenges for the management of transmission and distribution grid, since they are intermittent and the generation doesn't always match the demand. Now, moving to the second section of the presentation, you see renewable products, renewable and waste products, and they are classified into 4 groups. Now, this is especially important for non-combustible fuels. The classification is based on the form of primary energy of a given product, considered from a statistical point of view, and how this form can be converted into another. We consider the first energy form for which multiple uses are practical. And let me explain that with an example, looking at the first category over here on the left, non-combustible electricity only renewables, and for example, thinking about wind and hydro. So the energy from the wind or the water flow for hydro first generates mechanical energy by forcing the rotation of the turbines, but then in almost all of the cases, this mechanical energy is directly converted into electricity. So this is why we chose electricity as the first type of energy produced by this type of plants, and that is commonly used. For the second over here and the fourth group over here, we consider the primary form as heat. So in particular, for the second group, it is the primary energy, but actually two outlets are possible. So it can be directly used. That's the case of solar thermal collectors for heating water in residential sector, in housing, but also for geothermal district heating. Or it can be used to generate electricity, as the case of geothermal power plants or solar thermal concentrated plants. In the balances presentation that will follow later in the week, you will see more in detail how to calculate the amount of primary energy for geothermal, solar thermal, and other sources, these non-combustible sources, and also the fact that the efficiency is based both on the source and whether heat or electricity is generated. We have the fourth group that I mentioned before that includes the heat extracted and moved from the environment by heat pumps. And in this case, it's not possible to convert it into electricity. So that's why it's in a separate category. And finally, the third group over here, which is the one of combustible fuels. And for them, we do not need to speak about the primary energy form, and they can be quantified, and they are the only form of renewable and wastes that can be stored for use at a later time. So we have stock change for them. Now, here you can see various types of solid biofuels and the general definition in the middle in our statistics. They are all considered primary products and reported as primary solid biofuels, except for charcoal. Over here, you see that in blue, which is derived from the carbonization of wood. Now, let's look more in detail at some of them, maybe the most uncommon. We have black liquor here, for example, which is a byproduct of the paper manufacturing process. And this is a liquid, but it's, let's say, reported in solid biofuels because it originally comes from wood, and also the composition and the use of this substance is more similar to a solid than a conventional liquid biofuel. Then we have also industrial waste, that it's solid organic matter, usually. So it's considered within solid biofuels. And the most common type of industrial waste is natural rubber components from waste tires. Another very important topic in this slide is how liquid biofuels are reported and the differences between renewable questionnaire and the oil questionnaire that you will see later on. In the renewable one, we report, and that's very important, only pure liquid biofuels. This means that you don't have to report the portion of liquid biofuels that are already blended with oil products. We report these blended quantities in the oil questionnaire. So let's read this example and see from that what is the correct reporting. So a country produces 1,000 kilotons of diesel containing 10% of biodiesel. And then half of this product is exported and the other half is used in road transport. So for production, over here, diesel and biodiesel obviously are produced separately before being blended. So we have 100 kiloton of biodiesel, pure biodiesel, which is initially produced, then blended. But the fact that initially it is produced as a pure liquid biofuel means that we have to report it in production in the renewable questionnaire and not in the oil questionnaire. Instead, for the other flows, trade and final consumption, they concern already blended products, so they have to be reported in the oil questionnaire, both for what concerns the total diesel, which will be 500 kiloton for export and 500 kiloton for road transport, but also the biodiesel fraction that will be 50 and 50. Now, coming back to the renewable questionnaire, after production, you will report the quantity also in the transformation sector, in the flow blended with oil products, to indicate both this use in the renewable questionnaire, but also to create a link with the oil questionnaire, where this quantity is not reported, we said that before, in production, but is reported in receipts from other sources, still on the supply side. This concept applies also to biogases when they are blended in the natural gas grid. Now, going instead, okay, here pure biofuels. So let's see the data sources and the types of data collection. So for the supply side over here, data can be collected from energy producers, importers, exporters, and there are usually fewer players in the mix. While for the demand side, they can be collected from several stakeholders. It can be households, enterprises, and then data can be collected through surveys or administrative data that we will see later on. But very often, an integrated approach is adopted, which means that we use several ways of collecting data and also making estimation where the values are not available. So let's have a closer look at the different type of data collection. And at the top, we have surveys, which are generally the best ways of collecting data since you directly collect what you need. So for example, if you want a consumption of an enterprise of a given fuel with a survey, usually you are able to collect that because the enterprise keep record of the amount of fuel used for the industrial processes. However, surveys are usually time consuming and expensive, so it's difficult to carry them every year, and you need to make a trade-off between resources and what is found by the surveys. So generally they are done every 2-3 years when it's possible, and then estimation are made in between in the gap years. Then concerning administrative data over here, they are generally data collected for non-statistical purposes from governmental bodies in response to legislation, policies, and regulation to track their efficacy and efficiency. So because of this, it's very important to pay attention to their definition, classification, and eventual inconsistency due to the fact that they were not taken first for statistics reporting, and also because sometimes administrators lack dealing with data and statistics. Then you have here direct measured data. For example, for renewables, this is the case of solar PV generation in the residential sector, where a distribution system operator could have this data. And finally, in case data are not available, you can and will have to make estimation or to model. And that's the case again on solar PV solar PV generation that can be inferred by the capacity and also by obviously other factors as irradiance, location, and so on. So before moving to the final part of the presentation, here you can find a list of data products published by the agency with the support of the data that we collect here at the Energy Data Center. There are many free products, you see them here, so I leave you to explore the links later on. Now, we move to the questionnaire. We see that there are 7 different tables, actually 9 of them if we include heat pumps, and we use this questionnaire to collect in a central location the data that you have previously collected, validated, sometimes estimated, and sent us. For the countries that do not submit the questionnaire, I think this is still a good example to see how we operate, the tool that we use, which product, which flow, the definition we collect data for. And in addition, we will show you some validation of the data that we can make directly from the questionnaire. And so it will be a useful exercise, hopefully. So the first table, it's the one where we report the gross electricity and heat production. Electricity at the top and heat production at the bottom. So it is divided into these 2 parts, and gross electricity production is reported in gigawatt hour and gross heat production in terajoule. And we have also 2 columns, actually 2, and the third is a total. And the 2 columns differentiate between main activity producer and auto producer. The definition of main activity producer is an economic unity whose principal activity is to produce energy, whereas instead auto producer have other principal activity than producing energy, but as we saw, and that's the case, for example, of refineries. We saw that in the presentation of Susanna before, but then they also need energy to support their operation, and they might produce that locally. So these different type of producer are further split in electricity, combined heat and power, and heat producer. It's a bit small over here. I apologize for that. And an important concept that will be repeated with much more details in the electricity and heat presentation is the fact that for what concerns heat, it must be reported all of it for main activity producer and only the heat sold to third parties and not the one that is auto-consumed for auto producers. Now you see probably the most important table and for sure the largest one of our questionnaire with 13 energy products listed across the top and more than 60 flows listed in the horizontal dimension. And this is very similar to what you see in the energy balance, but every column represents a commodity balance of a product, and actually the units of this commodity balance varies from product to product. So regarding the definition of energy product, we follow the international recommendation on energy statistics from the United Nations, and most products are reported in terajoule on a net calorific basis, except for charcoal and liquid biofuels, which are reported in kilotons. Looking at the rows, you saw that already in the balances presentation, they are divided in different sections, starting from supply, transformation, and energy sector, and final energy consumption. So I will not repeat that much, but I just want to say that obviously this reporting of consumption in the energy sector and final consumption follows the international standard industrial classification, again, from the United Nations. Now, table 3A, which has 5 parts and contains information about electrical capacities and more in general, technical characteristics of installation. And this information is very important because it can be used to verify the production data or entered in other tables. So the first part over here, this one, collects data on the net maximum electrical capacity of renewable plants, which means the maximum available capacity for generating the electricity, which is then transmitted by the plants, net of the capacity used to power auxiliary components. So if electricity generation is reported in table 1 that we saw before, then capacity should be put here in megawatts. Then we have solar collectors over here. The unit is 1,000 square meters. And it's important to know that here we don't have the capacity of solar PVs, which goes instead here, neither the one of solar thermal power collectors. And then we have over here production capacity for liquid biofuel in kilotons per year, and finally average net calorific value and density for various liquid biofuels and also for charcoal. An important topic that I want to specify here about the previous table, table 3A, is the collection of AC and DC capacity data for solar PV. And it's something we introduced only last year, but it's a very important topic. So as you know, a solar PV system is composed by panels that produce electricity in direct current. And then generally this current is converted to alternate current through an inverter. So we have a capacity, which is the sum of the one of the panels installed, and it's in DC. And then we have a capacity of the converter in AC. And for design reasons, and to maximize the return on investment, because the inverter is generally a very expensive item of a solar PV power plant, usually the two capacity do not match, and the ratio between DC and C can be up to 1.5. So basically, the capacity of the panels can be up to 50% higher than the inverter power rate. So for this reason, we ask now in the questionnaire to report both capacity for a given plant. This is very important for solar PV, which is a very important product. And if one of the two is not available, then we will perform estimation, or you can perform estimation as well based on the data from experts in your country. And this is a very important topic also for the countries and the contacts that do not submit questionnaire to us, but it's important for them to clarify with their data provider what type of capacity data are we talking about, and to put that explicitly in their dissemination. Then coming towards the end, we have table 4 that gives a detailed breakdown of production of solid biofuels and biogases over here. So the solid biofuels, we saw them before. Biogases, there are 3 types of them. And what is important here is that the sum of the subcomponents that it's calculated over here must be equal to the one in table 2 reported before, and both for solid biofuels and for biogases. Then we have table 5 and 6, which are about imports and export by country of origin and destination. And at the moment, the data are collected in kilotons and concern only liquid biofuel and wood pellets, which are the most traded commodities, but there could be changes in the future. And let me also give some information about a new table, table 7, about non-energy uses of renewables, which we just implemented also last cycle. And in terms of flows, this table mirrors the one of the energy sector and final energy consumption, but we do not collect all the non-energy uses of renewables, but only the renewables which are used to replace fossil fuels. So if fossil fuel were reported in previous cycle in final non-energy consumption and now have ceased to be used because substituted by renewables, then those should be in the scope of energy statistics and reported here. So some examples are non-energy uses of biogases that replace natural gas as a feedstock, or liquid biofuel that replace naphtha, LPG, or lubricants in the chemical and petrochemical sector. And there are also other uses for solid biofuels to replace coal products in the industry sector to produce dyes or fungicides. So to clarify, still there are several uses, non-energy uses, of renewables which are irrelevant to energy statistics. For example, solid biofuel used in furniture or as a construction material, and alcohol used in the food industry. And final, a schematic overview of the relationship between the renewable questionnaire and other. So renewable questionnaire has a strong relationship, especially with electricity. We saw that before. The same values reported in table 1 for the same fuels should be reported in the electricity questionnaire, and also with oil. We saw before in the case of liquid biofuel blended with fossil fuels. And these links are very important, and we use them to validate the data submitted in the various questionnaire. So lastly, some helpful links specific on renewables, documents that might be of interest to you. So I will let you look at them later on. And thank you for your attention. Here is our email addresses if you have questions.